So let's take a look at section 2.2. This is the final section for week 1. After this section, you should be able to complete the lab. Make sure that you watch those videos for the lab. It will give you instructions on how to complete it and what we're looking for. So we are going to be looking at histograms and dot plots and stem and leaf plots. We're going to talk about the shape of a distribution. We're looking at discrete and continuous data. So first, this data here, it represents the number of available cars in a household based on a random sample of 50 households. So basically, we polled 50 different households in the U.S. and asked them how many cars do they have. And this is cars that are available, not cars that are up on blocks in the driveway or in the garage, not project cars that don't work. These are cars that you can actually drive. And this is just the raw data. So remember, the raw data is just after we've asked a bunch of questions, we just wrote down all the answers and didn't organize it in any way. So this hasn't been organized. It is just the actual raw data. So here is my frequency and relative frequency table. So these little tally marks, as I counted them up, I put tally marks in there. You don't have to do that, remember. So for 0 cars, that occurred 4 times. So of these people that we asked, 4 of them said that they have 0 cars available. So remember, in order to do relative frequency, we count up the total number of people that were asked. There were 50 people asked how many cars they have, and 4 of them said 0. So we do 4 divided by 50. That gives us 0.08. 13 had 1 car. 13 divided by 50 is 0.26. Remember, this is how we do the relative frequency table. So now that we have frequency and relative frequency, let's do some organization here. We're going to do a histogram. So the difference between a histogram and a bar graph, a histogram has rectangles, just like a bar graph, for each class or category of data. The height of each rectangle is the frequency or relative frequency of the class. So same thing with the bar graph. It's the frequency or the relative frequency. The width of each rectangle is the same as the rectangles. Just like with the bar graph, the widths are the same. The difference here, the rectangles will touch each other. I know this seems like it's trivial, but this is the difference between a histogram and a bar graph when it comes to discrete data. It's going to look different when we are getting to continuous, but with discrete data, pretty much the only difference is that the rectangles are going to touch each other. So once again, I'm going to draw the histogram for the frequency and relative frequency. Here's the frequency histogram. See how my rectangles touch each other, and along the x-axis we have number of cars. As with bar graphs, our y-axis here is frequency. Remember, the y-axis is always going to be frequency or relative frequency. So with the relative frequency, same thing. The rectangles touch each other. My y-axis is relative frequency. My x-axis is number of cars. So the only difference here is that the rectangles are touching each other. That's the only difference between the histogram and the bar graph with discrete data. It's going to look a little bit different with continuous data. So classes are the categories in which the data is grouped. When we have a large number of different discrete data values, or we have continuous data, we use intervals of numbers when we create our classes. So this data here represents the number of people ages 26 to 64 who are currently work disabled. So here we have larger numbers. So our classes need to be the same size. So take a look here, 25 to 34, 35 to 44, 45 to 54, and 55 to 64. Each of these classes represents 10 years. And then these are the numbers in thousands over here. So the lower class limit is the smallest value within that class, while the upper class limit is the largest value in the class. So for example, for this first one, the lower class limit is 25, the upper class limit is 34. The class width is the difference between the consecutive lower class limits. So for example, hold on here, let me get another pen. So we look at the difference here. So we take 35 minus 25, we would get 10. So our class width is 10. I know that seems really intuitive. It's not something I should have had to explain, but I just want to make sure that you understand what I'm talking about here. So once again, the class width is the difference between the lower class limits. So let's talk about organizing the data. So this data represents the time between eruptions of the Old Faithful geyser in Wyoming. So somebody took a random sample of 45 eruptions and they wrote down how the difference between them, or the time between them. And it looks like this is probably in seconds. Yes, it says in seconds right there. So we have all of this raw data down here. So the smallest data value is 672 and the largest is 738. So pretty much here you just decide, you can either decide how wide do I want my classes, or you can decide how many classes you want. Those are two different ways to figure out your class width. How wide do I want it? And then that will give you the number of classes you have, or how many classes do I have? And that will give you the width. So here I decided I wanted a class width of 10. So here I just took a number. So my lowest class value here, or my lowest data value, was 672. So I just rounded it down to a nice pretty number. I rounded it down to 670. My highest value is 738. And so it's not really a pretty number, but I've got 739 there. But so that's just slightly above. So make sure that your values, all of your data points, are going to fit in the classes. So here, all of my data points are going to fit. The top is slightly higher than my highest data point. The bottom is slightly lower than my lowest data point. So here are my classes. They are 10 wide, and I have 1, 2, 3, 4, 5, 6, 7. I have 7 classes. So I put them in a frequency table, and I did tallies. I counted them, how many are in each one. It is okay to have a class with 0. That's perfectly fine. We're just not going to have a bar. We're not going to have it's not going to go up at all. That is perfectly fine. So I have the frequency, I have the relative frequency, I've got all my classes there. Now let's make a histogram. Actually, let me show you this one first. Sorry about that. So if I decided to have 5, my class widths to be 5, take a look at this. I'm going to have all of this here with 0. This is not going to make a very nice looking histogram. This is why I chose 10. So if you choose a class width that doesn't work well, that you have a lot of zeros, then make it a little bit wider. Or if you decide to do that and you end up with way too many classes, because take a look at how many I have here. If you end up with way too many, then just back it off. Make your class width a little bit wider. There's not a hard and fast rule on this. So here's my guidelines for determining the lower class limit of the first class and the class width. Choose a lower class limit of the first class. So once again, choose a number that is a little bit lower than your lowest number. Okay. Then you determine the number of classes you want. So you want between 5 and 20 classes. You're not going to want 50 different bars on your histogram. And just your class width would be the largest data value you have minus the smallest data value you have, divided by the number of classes you want. Remember, the other way to do this would be to decide what you want your class width to be, and then you would divide that. Sorry, you would take the number of classes and that class width, and divide it by the largest minus the smallest. Sorry. Okay. So suppose you are considering investing in a Roth IRA. You collect the data in table 12. So this is my table right here. This is the table 12 from page 79 in your book. It represents the 5-year rate of return in percent adjusted for sales charges. For a simple random sample of 40 large blended mutual funds, construct a frequency distribution of the data. So I want you to determine, so right now, I would like you to take a look at this, figure out what your lowest value is and your highest value, and I would like you to attempt on your own to figure out a good class width. So go ahead and pause this and see if you could figure it out with your lowest and highest, determine how many classes you want and your class width. Right, so I hope you did that. So what I did is I did 8 to 899 because my lowest here, so take a look here, I have 8.28, I have 8.71. What is my lowest? 8.28 is my lowest, so I decided to go with 8 for my lowest here. So I have 8 to 8.99, then 9 to 9.99, so I used 1 as my class width. And then my highest, let's take a look here. My highest, I have 19.43 there. It looks like that might be my highest. So 19.43 is my highest. And I have zeros in here, but that's not going to cause a problem. If I ended up with too many more, it might. If you wanted to make your class width 2, that would have been fine as well. You would have ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12. You would have ended up with 6. It's a little bit low, but that would have been okay. So here's my lovely histogram. So if you notice by looking at this, my classes down here are wonky. These are not the ones that I had in my frequency table. The reason is because I created my histogram in Excel. Excel decides its own class widths. Excel is weird. It will not allow you to choose your class widths. It does it for you. There are ways to choose the number of classes that you have, but it will not allow you to choose your own class width. It does its own thing. So I don't have labels, so labeling down here would have been interest rates. And this label here would have been frequency. So that would be my histogram, my frequency histogram. And then, of course, you could do a relative frequency histogram as well. I didn't do one. But hopefully that makes sense. If not, send me an email or post a question in the forums, and you can get a little bit of help with that. So let's take a look at stem and leaf plots. So stem and leaf plots are not something it's not something we're going to do a lot of, but it is something that you need to know what it is. So they're a really strange way to organize data, but it is a thing. It is something that is done in stats. So it uses the digits to the left of the rightmost digit to form the stem, and the rightmost digit forms the leaf. So for example, 147 would have 14 as its stem and 7 as its leaf. Let me show you what this looks like. So the stem is going to, if we have a decimal, the stem is going to represent the integer portion of the number, and the leaf will be the decimal portion. We're going to take a look at the geyser eruption data. So here's all of that. We already have used this data before in our histogram. So, a second here. This is not the geyser eruption data. So we're not looking at that. Here, let me get rid of this. Sorry about that. Ignore that. I'm going to get rid of that in the PowerPoint that I upload into my Open Math. Sorry about that. Okay, so we're looking at the Roth IRA data here. So my stem, let me see here. So, sorry. First, we have the frequency distribution. Where I am so confused at what I did here. Okay, let's get rid of this page. So once again, I'm going back, and I don't want to redo this whole video, so you guys get my gaffes and the PowerPoint that I upload is going to be completely different. It's going to get rid of this. I don't know why that landed in there. So once again, we're going to look at the geyser data. We're going to look at the geyser data. Hold on here. Okay. So go back to the geyser data, and here is my stems. So for example, like 6, 7, I have a 678. So I'm going to put an 8 right here. I have a 672, so I'm going to put a 2 right there. My first data point was 728. And I should not have 2 of these, so I'm going to get rid of that. Let's pretend that wasn't there. And I have a 723, 735, 703. So we just put all of these on here. And I'm putting them, notice that I'm just putting them as I see them. But this is not how it's going to be organized in the end. So 1 second here, 726. Hold on, I'm having issues. Okay, so I'm just going to put be putting all of my data in here. Okay, as you can see, so 716, 736, 719. So I don't want to put all of it in here, but you can see what's happening. So 696, I'm going to put a few more in here, 695, 718. You don't want to just sit here and watch me put in all the numbers. 722. It's okay if you have more than one. If you have more than one, you just need to put it in there more than once. 711. Every single data point needs to be represented. So I'm putting them all in here. So let's pretend that I put every single one in here. So this looks kind of a mess. So when your final product should have them organized. Let me rewrite this. 6, 8, 6, 9, 7, 0, 7, 1, 2, oops. 7, 2, 73. They should be organized in numerical order. So for example, right here, it should be 2 and then 8. And then down here should be 6, 9, 5, 6, 6, 9. So they need to be in numerical order, smallest to largest. So this would be my, well, if I had all of the data points in there, which I don't because I didn't go through each and every all the 45, but this is my stem right here. And then these would be my leaves. So this is my stem and leaf pot. This is not something you're going to have to do on a test. This is not something that you're going to be doing over and over again. This is just kind of informational for you. Okay, so I would like to show you now how we do this with decimals. So 1 second here. So if I have a decimal, so here is the unemployment rate for each of the 50 states. So I have all of them organized. So right now, so the way that it works is my stem will be the integer and the leaf will be the decimal. So take a look here. So we have a 2.8. We have 2 on the left, that's my stem, and then the 8 would be on the right, and that's my leaf. So I had 3.8 3 times. But notice how these are organized. These are not in numerical order. They're not from lowest to highest, so we would need to redo that and organize them so they look like this, lowest to highest. So I have 2.8, I have 3.2, I have 3.2 3 times, then 3.3, 3.8, 3.8. And make sure that you look at this in the textbook as well. because stem and leaf plots are a little bit confusing. And if you have questions about it, send me an email, post a discussion in the discussion board. We will talk about it. Let's talk about identifying the shape of the distribution. This is something really important. This is something that we're going to be talking about a lot in this class. So if nothing else makes it into your brain, the histograms and the shape of the distribution are important. So actually, I think I'm going to stop this here, and I'm going to do a whole new video just on this. So if you needed to rewatch this, you can.